that I had faced. So today I'm just going to speak about recent trends in speech recognition. So what I'm planning to cover in today's session is basically, I have worked in speech recognition toolkits and the latest speech recognition methods, whatever is available. I'll give an introduction to that and I'll give an intro to the toolkits. First of all, what I'm planning is tell about an introduction about speech recognition. What is speech recognition, how it is actually happening, and what are the current successfully evolved methods which is being used across the world for speech recognition. So first of all, let me start with automatic speech recognition. We call speech recognition as automatic speech recognition. Basically what it means is I'm speaking something right now. Okay, it is a audio or a voice. In general, it is an audio signal. We call it as an acoustic signal. What happens, this is a audio. This will be converted into a text. Okay, so if I'm going to record through a microphone, say, here I've given an example, like my number is 7390274. Okay, so my recording is going to be a sentence telling myself telling some number. Okay, so what is the recording? My number is 7390274. Okay, so this will be recorded as an audio signal. So that is what I've given in the left hand side. It will be recorded as a signal. Okay, and what I expect from the speech recognition system, I call it a system because if I give the signal to it, it will interpret the information in the signal and give me back the corresponding message over here. So the corresponding message here is the text format, corresponding text of whatever the sentence that I have spoken here. Okay, so basically the speech recognition system involves converting or mapping an audio signal to the corresponding text information. Okay, so that is the basic idea about speech recognition system. So why we are going for speech recognition system? Basically, it is why we started with, all of us are very comfortable with speech as a mode of communication, the human to human communication. If I want to talk to my friend or anybody, basically normal speech conversation is very comfortable rather than like sending a message or so and so. Okay, if I'm going for speech human to machine interaction, where that comes, so today's example, we have something called as Alexa. We have a voice assistant system, okay, which I'm using it in smart homes. Okay, if I'm in my home, if I'm having Alexa, a voice assistant system, I will connect it to most of my devices in my house, which I can control. I can turn on my AC or turn off most of the electronic equipments in my house. I can connect to the camera to monitor. Okay, so many things. The human and machine interaction is made so much easier through speech recognition. Okay, so I can have a lot of voice control. So one is Alexa, second one is chatbots. Sir? Okay, the second one is chatbots. Okay. So the one is chatbot. What we mean by chatbot is people would have been familiar with when we are going through some websites, we will have a window opening at the bottom where if you want to have some queries, it can be answered over there. Okay, something like chatting, but chatting not with another person, but to a machine. The machine will answer a query. Chatbot. Next is call center help desk. So these are very simple everyday examples that we are having now. Okay, so call center help desk, what happens is when we are first requesting, for example, if I'm having any issues in my mobile phone or in my SIM card, if I'm initially calling to the customer service directly, it will not be connected to the other end to a person. Initially, it will be connected to a system. Okay, so the system will try to solve some queries. If I really want to speak to the customer service person in person, then I'll be redirected. So the advantage over here is most of the tasks can be simplified through a machine. All right. So these are some simple examples, and we have n number of applications using the voice recognition. So first one is voice recognition in smart TVs. We don't have to manually change the channels. We can use voice recognition to give commands to change. For example, if I want to play a movie, just play so and so movie. So that movie, that command will be taken in by the mesh, like TV, smart TV. That particular movie will start playing. In bank applications, this is very useful because, and second, one thing is this is very useful. Second thing, we have to ensure that it is highly secure, because I don't have to log in every time using a username and password if I want to make some transactions. I can have a voice recognition application or system which can be a part of my mobile phone as an app. Okay. What I can do is I can just give instructions, like if I want to check my balance, I can say some similar to Alexa. I can have some other app, I'm just giving a random app. Okay, into that app, I can ask like, what is my current balance? Okay, so this app will be connected to my bank account through banking. It will retrieve the balance and give back to me as a speech. Okay, your account current balance is so and so. Second, if I want to transfer money to somebody, just I'll say transfer money to my mom. Okay, say what is the command I want to speak here is transfer 2,000 rupees to my mother or to mom. So what happens here? I will have a record of the account of my mother in over there. Okay, so or the corresponding person I want to transfer, say some Shalini, some person. Okay, the account information will be there. Transfer 2,000 to Shalini. What happens? That amount will be directly and immediately transferred to that particular person. So this is really advantageous in banking applications. You don't have to go through the hassle of logging into the account, ensuring all the process, taking and spending time. Within a fraction of a second, you can do all the process. So we can have this applications if somebody is driving. So if the person is driving to his office, okay, on the way he can check his, all the records, make all the transactions, relaxedly go back to his office. Next, smart home assistants. We have Alexa and a lot of applications we have now. So what is smart home assistance is we have a small device. This device will have a voice recognition system connected a part of the network in our house. Okay, so through voice, we are going to control the appliances in our network or control, basically electronic appliances is what as of now we are controlling. Or if you want to, for example, if there are kids at the home, through Alexa, they can communicate with the kids, they can monitor what they are doing, and so many things are actually happening. And the next one is voice recognition for translation application. So this is very interesting and very useful today's scenario because, for example, I may not know Korean language, but I'm going to Korea. I might end up in some extremely rural area where English is not available. Okay, so in that case, I might be stuck up without any help. We can have a small app, a voice like a translation app, where if I'm going to speak in English, I want to translate from English to Korean. Okay, so this translation app, what it will do is, I will speak, say something in English, that will translate to Korean, and that sound will be the output of that app. Okay, if I want to ask some help, for example, the request is going to be like, where is the nearest bus stop? In that case, the app will translate this sentence, where is the nearest bus stop, to Korean, and that will be the output. As in, it will be given out at the speaker of my mobile phone. Okay, so the other person who's a Korean, who's not familiar with English language, he will understand it. He will reply something in Korean. That will be again translated through this app, and I can listen that back in English. Okay, so this is another application. And another interesting application is earlier medical diagnosis. So this is related to recordings. For example, Alzheimer's disease, we have one of the symptoms, not diagnosis steps of Alzheimer's disease is their speech will be affected. The person, an earlier stage of Alzheimer's disease, their speech or the way they speak will be affected. So if we can record and analyze the speech signal of a normal person and a patient having Alzheimer's disease, okay, we can identify significant patterns in this. So this will help in early detection of a particular Alzheimer's disease. and medical diagnosis. Apart from that, we can have speech disorders, people who are having the cleft lip and other issues. They will not be able to pronounce properly, they will not be able to speak properly. Okay, so if they want to use some voice recognition applications, that will be very difficult for them. So what we can do is, as a that analysis part, okay, so if they are basically, they won't be able to pronounce vowels properly, a e I o u, that will not be able to, that they will not be able to pronounce properly. So what we can do is, we can have a pre-processing step or pre-end step, a module before the voice recognition system, where the voice from the cleft lip person can be analyzed and mapped to a regular speech, so that they can make use of all these voice recognition systems available. Okay, so AI assistants that can recognize your specific voice. An example could be Siri. The option in Siri is, we can customize Siri application with our own voice. As of now, we know that anybody records something or wants to communicate with Siri, it will respond. But it can be customized for a specific voice also. So only if that particular voice, person having that particular voice is speaking, Siri will respond. Otherwise, it will not respond. Voice identification for security. Why this is? Because our voice or the way we speak actually reveals a lot of information about us. First thing, the dialect we have. Basically, all of us will have a dialect depending upon the region we are from. Okay, dialect information will always be there in the voice. Based on that, by recording and analyzing the voice of a person, we can find out where the person or which region the person belongs to. Second, the age, gender. So all those things we will get more or less about an information about a person through voice identification. So this can be used, this actually applies for recognition in forensics and criminal identification. And voice identification in security is, I can customize my home, I can ensure security by customizing the application using my voice. Only if my voice is played, the door will open, or I will get access to a particular room or lab. So these are some of the interesting applications available. So one thing, if you notice, a lot of applications involved, for example, in banking applications, smart home assistants, it is not like a very big system or a server or a high computing facility which is going to run somewhere. We bring it to the users as a simple application which can be installed in their phones, or a small device which can they make use of. Okay, so that is where the speech recognition system today is. They bring the application to the user in a very simplified way, which is very helpful for them in their day-to-day life. Okay, some of the fields or areas in which the speech recognition has evolved is, one is multilingual speech recognition. Okay, so in general, we keep the language English as a standard for comparing the recognition performance. So if you see multilingual speech recognition, if we take it in India, okay, so regular speech recognition could be, I can have a recognition system for Tamil. So what the system will do, if I have audio recordings of Tamil speech of say some 5 people, if I give it to the system will translate or transcribe it and give it to me the corresponding text, Tamil text. Okay, so multilingual, and if this is for Tamil recognition system, I can have for Telugu one system, Malayalam one system, Kannada one system, Hindi one system. So in multilingual, what happens is, I don't want to have 5 or 6 different systems. I want to have a single system. Let me take a small example, like I want to have it for Hindi, Tamil and Telugu, 3 languages. Okay, I want to have a single system. If I speak in Tamil, it should be able to recognize. If I speak in Hindi, it should be able to recognize. And if I speak it in Telugu, it should be able to recognize. So how it is possible? It should be trained for different languages and mapped with the corresponding grammar in different languages. Okay. So this, I will talk a little about it when I explain about speech recognition system. Speech-to-speech conversion is what I just told about voice in translation applications. It converts from English to Korean language, one speech directly to another. This is not a simple process. First, it will convert from English speech to English text. From English text, it will translate into Korean text. From Korean text, it will again generate a Korean speech. So it involves two different systems combined, collectively working together. Speech to text, text to speech. At one end we have English, another end we have Korean. So this is a very highly useful and interesting application. And recently we have people have focused on telephone speech recognition. Why I'm telling recently is because in 2021, one of the leading conferences, Tier 1 conferences, they released data for telephone speech, related to telephone speech, to recognize, to build an efficient recognition system. Okay, so why telephone speech, you might think, is because there are a lot of cases where, what do you mean by telephone speech? That is the first thing I want to say, because if we, all of us would have used landline connection as well as mobile connection. So there is an obvious difference in the sound we hear from telephone landline connection and mobile connection. So that is because the speech signal which is being transmitted along the channel, telephone channel, is being attenuated to accommodate that channel capacity. So some information is actually missing in telephone speech compared to the others. Okay, so this is one of the areas where we are focusing on research. Okay, so we know that the challenges in speech. So the challenges in speech actually arrives from the variations in the speech signal, the speech audio which has been recorded. What are the possible variations in the recorded signal? Could be, first one, it has a significant variation due to age of a person. For example, we obviously know that if it is a small kid of 5 years or 10 years, the way they speak is very different from elderly person. And I'm sorry. And it is different from somebody who's of age, say some 20, 25. What is the difference is because the pitch, we call it as pitch or frequency, that information varies. For a kid, the pitch or frequency in range which they speak is very high, okay, and the elderly person, it will be very low. Okay, this involves something, this is highly related to the speech production mechanism in each individual. Second one, gender. In general, female or women have high pitch or high tone compared to men who have low tone or low pitch, or you can tell it as bass voice. Okay, speaker disorders. I just told about cleft lip. People who have disorders, they will not be able to pronounce certain vowels properly or certain terms properly. And background noise. So background noise is one of the biggest challenge starting in very long back in speech recognition. Why? Because we record an audio. If there is going to be a fan, that sound also will be recorded. So if I'm going to train a model with a proper speech without any noise, and if I'm going to test it with this noise, the machine will not be able to properly recognize this, because this noise, the machine will think that is also a speech sound. Okay, so we have to train that system with noise also. Transmission channel, just now I gave an example of telephonic speech. Emotion is one of the highly challenging area. Why? Because if a person is very angry, the way they speak is very different from the time when they are very happy or when they are very sad. Okay, the tone in which they speak, the rate in which they speak, okay, and the speed in which they speak, the duration. So if they are very angry, they will speak it very fast. If they're very sad, the duration will be little longer. Okay, so the emotion actually affects the speech a lot. So what they do for emotion is they analyze the emotion and find the trend in emotion to map it to the speech recognition system. Speaking rate. I might speak very fastly, someone else might speak very slowly. Okay, so this will affect the recognition system. These are the challenges in speech recognition. So why I've given this is, this will give me the basic insight of what is a recognition system. I told If you can see at the top, there's a speech signal. This is a mapping from the speech signal to the text. So the text could be, if music could be the food of love, and the corresponding speech signal is this. Okay, how this is mapped? First, audio has to be mapped to the corresponding text. So what is happening? First of all, I'm taking a speech and applying some feature extraction methods. Why feature extraction? Because the signal will be having repetitive information, and the signal is very long. Okay, I want to take only the relevant information from the signal. So extracting the relevant information from the signal, I call it as features. We have standard handcrafted features for speech recognition. One is substral features, mel frequency substral coefficients. Okay, that is what is given here, MFCC. Why I'm telling it handcrafted is because speech recognition system imitates how we understand what the other person is speaking to us. Okay, if somebody is telling me, go back to the last page. Okay, so that is a voice. I perceive that sound. I understand what they are telling. That is what speech recognition is actually doing. This perception in human has some significance based on frequency. Okay, so up to 1 kilohertz, the perception is even. After that, it varies logarithmically. So what this handcrafted feature does is, it is going to have filters based on the human perception. Okay, so accordingly, it will filter out the speech information so that the recognition is better. So this is a handcrafted feature for speech processing. Basically, it is used for recognition, speech recognition, speaker recognition, and so on. Then we have acoustic model based on Gaussian. We call it as Gaussian acoustic model. It is based on probability. Okay, so the feature we represent it as O. The Gaussian acoustic model, what it does is, basically, I have, for example, if I take this signal, it is based off a set of sounds. So each sound we can represent it as phoneme. So I don't think I have to explain what is phoneme over here. I'll just give a brief of what is phoneme. It is a basic representation of a sound unit in speech. Okay, so what it is used here is, I'm going to have a representation for each sound unit for the audio in the sentence. Okay, for example, let me take an example for numbers from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so in Gaussian model, what I will have, a simple, if I'm not going for phoneme, I'm just going for a word model. What I will have is, for 1, I will have a model. For 2, I'll have a model. For 3, I will have a model. Totally 10 models I will have. So what happens, next time when I pass a sound through the model, it will give me the probability values. The model which is giving the highest probability, I will consider the sound belongs to that category. So if, for example, if I'm going to pass the sound for number 5 to all the models, the probability outcome of this model number 5 will be very high compared to the rest. So I will able to know that the sound or the feature which I've passed belongs to the category or word 5 here. Similarly for phonemes, why we are going for phonemes is, it is more efficient if we define a model for phonemes rather than words. Okay, we can better develop a recognition model. We have, say, for example, in English, we have collectively, we have, say, some 39 phonemes. Rather than if we have in my vocabulary, if there is going to be some 5,000 words, I don't have to create model for 5,000 words. All I can do is I can create model for 39 phonemes, which is comparatively easy and more efficient. Okay. Then, as of now, what I've done, I have a pattern or model for my audio signal. Now, for example, if I have for all this, if you see, if music be the food of love, this is the sentence. Right now, I have a jumble of all the information. All these sound, all these, for example, if we take it as a word level, okay, it is not in order. What I have now is not in order. If I use the acoustic model, what I have now is not in order. I know that in the like in the speech signal, these are the words present. How will I know what is the order or sequence of this word? It should have some proper grammatical format. Okay, so it should be in proper order. If should be followed by music, if cannot be followed by food or off. For example, if and off will not go together. So this grammatical sequence or context is given by all this phoneme likelihoods, HMM lexicon, Ngram language model, all those things. So this will help me to identify the possible sequence of words coming one after the other. Okay. So phone likelihoods is if I take one sound, okay, music. Okay. So if I start with mu, okay, it follows by is, then sick, music. Okay. So in the case, what is the probability of phones which is following one after the other? Lexicon is nothing but if we have two words, for example, one word is I'm going to department tomorrow. Okay, that two is different from I want two different sets of results. The second two represents number, but first two is different. How we pronounce is same. First one, what I told, I'm going to department tomorrow. Second one, I want two sets of results. Both are pronounced in the same way, but both have two different meanings and both occur in two different contexts. That is given by Ngram language model. Based on the context, it will give me the correct word to be used here. And what is the reason of lexicon? It will identify which is the appropriate word to be used here. Out of two and two, which is the appropriate word. And V2B decoder basically will find the correct sequence using all this information. V2B decoder will find the correct sequence and give me this sentence from the audio signal. So I hope you got this part. So why I'm explaining all these things is we, first of all, I want to insist on how audio is mapped to the text. Okay, so that is where the major part is. So I have a speech signal. I extract the features. So this we call it a spectrogram. This image here we call it a spectrogram. It is actually a time frequency representation. Earlier days in conventional models we used the speech signal. We extracted features from the speech signal and given to the recognition system. Now in the current trend, what we do, we take a speech signal, create this representation, spectrogram representation, we pass this as such to the model. Okay, so this I call it as features. So all the information x1 to xt, what happens is this image is being taken frame by frame and given as x1, x2. X1 will be say some, if this is going to be of length, since it is time, this is frequency. So the x-axis is time, this is time, and this is frequency. So in time, I can take some every 10 milliseconds. So every 10 milliseconds will be first small part of the image. Then next part of the image. Frame by frame, it will be taken. And this is acoustic model here. The pronunciation models I told. The language models will give me the final context. Why is the expected output what I want here? Okay, so that is obtained by Ngram models. We have the standard male frequency substral coefficients as well as the spectrogram. Okay, so male frequency spectrogram coefficients are extracted over. If I'm saying telling a sentence, it probably will the duration will be probably around 2 or maximum 3 seconds. If it's going to be a short sentence of 5 words or something. Okay, so in that case, let me take this example itself. So this sentence, it is extracted over the speech frames. This will hardly cover 3 to 4 seconds. Okay, so in that case, I'm not going to process entire 4 seconds. What I will do, I will split that into small frames of milliseconds. 20 milliseconds. Entire 4 seconds will be divided into 20 milliseconds overlapping frames. The MFCZ is obtained over there. Spectrogram, this is exactly the spectrogram, this image. The second one, you can see, right? Above features, we have an image here. This is actually the spectrogram. So I have given an idea about speech, the features, HMM. So HMM basically gives me, if I have a feature, what is a probable corresponding phoneme representation of that feature. Okay, so first example, if you see word model for the word the, so in that case it has basically probably it has the phonemes DH, first one phone, the second phone will be AX. Okay, so if I take this model, if you can see, it has a starting point and ending point. The first one, it has a starting point and ending point, and there are some above the arrow marks. You have some numbers, probability value. They represent the probability value, and so if you see, if I train the model, what will happen is, if I'm passing the feature related to the word the to this model, okay, then when it starts, what will happen? At the starting point, you have two possibilities. It can go either to DH or N, but which is having high probability 0.92, it is DH. So it will go to DH. Okay, then it still has two options. One is 0.77, next one is 0.23. 0.77 is high, it is AX, then it ends. So basically what it tells, I have all these phonemes I have all these possible phoneme combinations in my recognition system. Okay, this particular model is for the word the. Okay, so similarly I can have models for like on, I, need, and so on. So if I have the audio for the word the being passed to all the four models, okay, this will give me the highest probability value compared to the others. For example, it will multiply 0.92 into 0.77 and give me the results. Okay. Similarly, the other models will have the corresponding probability values. So this will give me the higher probability. From this model will be chosen during the recognition step as the one of the final outcomes before the applying the language n-gram language model. So this is a acoustic modeling step. Okay, so this gives you the clear insight of what is happening in HMM. So HMM is hidden Markov model. That is, you can see this circles. If you see at the top, you have a circle that they are called the hidden states. Okay, at left hand side of each circle, we have a curve. We call it as Gaussian distribution curve. Basically, the probability value, whatever we have, is obtained from this Gaussian distribution. So what is happening here? This observation sequence at the bottom is going to be my features. I told you we have a spectrogram. We will split that spectrogram into small frames. So each strip over here will represent one of the frames in my speech spectrogram. Okay. So this will be given to the states or the acoustic models in my recognition system. The models will generate give me the probability value. Based on that, I can identify the possible state. What could be the state? So here the states are DH and AX. These are the states. So this will be combined finally into a word. Basically, this is a phoneme sequence, DH and AX. Using lexicon, I will get the word the from this model. If I apply the lexicon over here, first I will get the phoneme sequence through this model. Phoneme sequence is DH and AX. And if I apply the lexical information, I will get the word the. Okay. Now I have a set of words here. After that, I'll apply the n-gram model to get the sequence of words, finally arrive at the sentence. So before moving on, I'll just pause for a second. So I hope you understood what is happening in speech recognition. So if you have any doubts or anything, you can please feel to ask me. Otherwise, I'll continue. So is there any?
Highlighted some of the issues and the present state of affairs of speech recognition. Of
Yes,
course,
sir.
she has given various applications. Similarly, what are the challenges people face while we are implementing the speech recognition concept? And
Sir,
she has also
may I
taken.
interrupt? I'm
Hello?
sorry.
She has,
May I interrupt?
yeah, yeah,
If,
yeah.
actually, sir, I just paused in between so that if there is anything I can answer, then I'll continue.
I see, I see,
I'm
I see, I see, I see. Yeah, please, you can proceed further. Proceed further.
okay.
Yeah, yeah, yeah.
Thank you, sir.
Okay, okay.
So I believe that there are no queries.
Everything is reachable. People are listening to that. And you please
Okay, sir.
go ahead. Go ahead.
Okay, sir. Thank you. So I want to understand how efficient my model is. So how will I know whatever audio I am giving to the system, it is giving me the correct sequence of like correct sentence. For example, if I'm going to give 1,000 audio files to the system, I'll get corresponding 1,000 sentences. So in that case, how will I know it is how efficient our system is? So I have a performance matrix called word error rate. We have phoneme error rate also. Basically, what this error rate represents is, I have a sentence. Okay, the sentence could be today is Wednesday. 3 letters. First one is first letter. 3 words. First word is today. Second word is. Third word is Wednesday. Okay, so n is going to be the total number of words 3. I, D, and S are insertion, deletion, and substitution. Insertion is instead of 3 words in the recognition, I'll have more than 4 words. Okay, it is actually the fourth word is actually wrong. Deletion is one of the expected word is missing. For example, the second word is missing. I get the response only as today and Wednesday. Is this missing? Third one is substitution. Instead of is, I will have something as was, which is not correct. So these are the 3 possible error that can happen in recognition. Okay, so we can have it as word error rate if I'm going to consider my recognition output as words. It can be phoneme error rate if my recognition output is phonemes. Depending upon that, it will be varying. Okay, so these are the toolkits. We have HTK as hidden Markov model and Kaldi. So HTK completely works on hidden Markov model, which I explained just now. So we have a specific model for grammatical or linguistic information, which is nothing but the n-gram lexical information. We have separate model for acoustic signals to model the acoustic signal acoustic model that is using Gaussian mixture model like GMM, Gaussian mixture model, and we have features. Each step is separately as a model. In Kaldi also, the advantage of Kaldi is it supports the deep learning. The current whatever we have deep neural networks, it is supporting that. Okay, so whatever I spoke till now is conventional method, which is being there for some time. Now we have moved on to deep learning. All these separate models has been converged. If you see the first one is conventional method, we have separate models for each step. Second one is hybrid model. Hybrid model, one of the module is replaced using deep learning method. Third one is end-to-end ASR, that is what we have currently. What end-to-end ASR does is, I give a speech signal, there is only one system, no separate modules, it gives me a text out. A single system, a single network. Okay, so this is a basic idea about deep neural network. Okay, the circle represents neurons. I have an input layer where my speech signal will be passed. Okay, so if my speech signal is going to be of length, I'm going to take a part of speech. It could be say of length 160. Okay, it will be passed over here. And I have hidden layers where all the learning part is going, all the models will be, modeling part will be done here. And finally, I have the output layer where I will get the corresponding word. Okay, so I'll pass an audio at the input layer, I'll get a text at the output layer. All the feature extraction, acoustic modeling, language modeling, everything will take place within the hidden layers. So as of now, we have different networks, deep neural networks, currently standard methods which we are using based on this model. Okay, so some of the, I'm sorry, this is not E at E, it is actually E to E, end-to-end system. E to E, the number 2 and E. So I've chosen very few methods which gave really good results and which we could call as benchmark in speech recognition. We have lots of methods since we can say some 20, starting of 2010 and 2010, 11, they became as a standard. Deep neural network has become a very standard in speech recognition system. These are the benchmark methods available, which kept on evolving and improving the recognition performance in different aspects of speech recognition. We had different challenges like emotion, noise, and speaking rate. All those challenges, we can have benchmark results using these methods. I'll give a brief overview of what these things are. Okay, if you take the convolution neural network, we are going to pass, in general in speech, instead of passing an audio signal, passing the spectrogram, the 2D image to the network was performing, giving good results. Why? Because if you see here, the blue color, the background blue color actually represents no information. The yellow color and represents the information. The dark red color represents basically the pattern in the signal. Okay, so the yellow and dark red variations are actually representing the speech. If you see the vowel and the variations in the, it will represent the speech variations. The yellow basically will give you the unvoiced part, or the aspirations, all those things will be represented using the yellow color. So what happens in convolution neural networks is, I have a spectrogram here. Okay, it is actually an image. I take a small part. You can see the black box here, right? I'm going to take a small part of that image and I'm going to convolve the mathematical convolution over a filter. Okay, so what it is going to do is, it will capture the information in this particular small frame. This is my convolution layers. You can see the violet color boxes here. This is my convolution layer. So this information will be captured over here. So there are two steps here. First one, filtering and max pooling. So each step I will have, for example, within this box, I will have, if I convolve with a filter, I'll get a set of values. Max pooling is going to pick out the maximum value out of this. Okay, so what I understand, like what I will capture is, only the relevant information within this box will be captured at the outcome of this convolution layer. Okay, so this is very efficient in speech recognition. After that, I have something called as fully connected layers. That's nothing but each neuron will be connected to every other neuron in the next layer. Okay, then finally I have a softmax layer. This is going to give me the possible sequence of the expected word outcomes. Okay, so you can see there is an obvious difference between the HMM model we have seen previously and over here. We directly take an audio, and using the neural network, deep neural network models, we make the model, we train the model using several samples of audio. This is not just going to be one audio. I'm going to have, for example, I will have, say, several copies of the same audio, repetitions of the same audio. For example, if it is going to be a word, speech will be recorded, say, some 1,000 times. Okay, all the 1,000 will be given it for training, so that the network is efficiently built. Okay, then finally, if I take in a new audio of the word speech, okay, it will be able to identify the corresponding sentence and give me at the output the corresponding word speech. Okay, so this is convolution neural network. Basically, what happens, in each layer we have something called as weights and bias depending upon the equation. Okay, so accordingly it will alter depending upon the information. The weight and bias will keep on varying to efficiently learn this information. Okay, so the convolution network is about this. It is going to have filters which will convolve with the input. Okay, and based on the max pooling, we will get the information and pass it to the next layer. Okay, so the second one is encoder decoder network. Encoder, what is this? I have a feature. This feature will be converted into a fixer dimensional representation called a fixed dimensional vector HT. HT is a representation. So the feature vector is encoded into HT. We have very good working neural networks, deep neural network methods like LSTM, long short-term memory, RNN, recurrent neural networks. Using these methods, we can create this vector. So why this is happening is because my audio is going to be a continuous signal. The text I expected of this audio is just going to be 4 or 5 words. The matching, it doesn't exactly match. Some words will take more interval duration, some words will take less duration. Okay, so the matching, there is no proper matching between these two. That is why we are going for a fixed dimension here. Decoder, what it does, each step out of the previous step, depending upon the previous step, it will predict what is the probable word. Okay, if you see here, x1, x2, x3 are going to be my feature vectors. Like input features, the MFCC features or spectrogram, whatever we have, that we will pass it to the encoder. So this is the encoder part. You have RNN at each step. This encoder will give me a vector. Okay, so this vector is passed to the decoder. The decoder will, based on the first value, it will give me the first possible speech text output. Okay, so y1, y2 are my expected text outputs. So the decoding paths. Okay, next one is attention-based model. This is one of the models which gave very good results for speech recognition. So it started, I believe it started with NLP. Now it came into speech recognition. Okay, so the difference between attention-based models and this one here is attention-based models. We have, for example, if it is going to be a word cancel, it has like letters CANCEL. Okay, so in that case, in this word cancel, the starting letter or the first predicted letter is C. Okay, I have an initial context over here. Okay, so the attention-based model is based on some context. It will go and predict the next. I have a set of characters in my system, like in my recognition system. Out of all that, based on the given context, what is the next possible? So this is attention. Okay, so you can see initially C was recognized. Now, based on this, based on this, I'm going to choose the next letter A. Okay, and so on. Finally, this will repeat. Then next N will be chosen, C will be chosen, E and L, cancel. Okay, so specifically, I'm not going to decode with all possible, like decode based on using all possible scenarios. I'm going to fix a context initially. Only as the context as a subset, I'm going to go for decoding. Okay, so this is one of the well-established methods that came in around 2015, and it was very popular in 2018 and 19. It went to peak at that time. Listen, attend, and spell. Listen is where your acoustic component happens. Attend and spell is where your decoding takes place. So you can see here in the first block in acoustic model, at the bottom we have a set of neurons. At the level above, the number is reduced. At the level above, the number is reduced. What is happening here is the time resolution. Okay, time resolution keeps on decreasing at each level. Okay, here initially we start with very fine small intervals, then we keep on reducing that, we go up. So what is happening? Finally, we will end up with one possible acoustic model outcome for a given audio. This is given to the decoder. So it is kind of what is happening here. I have a context. Okay, based on that context, I'm going to find the next possible. Similarly, I have an acoustic signal. Okay, I'm going to improvise that acoustic model by fine-tuning based on the time resolution and give out the outcome of an acoustic model here. This outcome is given to the decoder to finally give me the possible sequence of the outcome. Okay, and the another one which gave really good results for speech recognition is connectionist temporal classification, which we call CTC. Why it is this? If you take, I told you we are going to split the signal, the spectrogram into small frames. If you see at the bottom image, there is a division. X1 is one frame, X2 is one frame, X3 is one frame, X4 is one frame. What will happen sometimes is the same information will be carried over in multiple frames, because it is like the frame will be very small. Okay, so that information will be covered only in multiple frames. If it is going to be uh, word do good, okay, so the good might be covered in say some 5 to 10 frames. Okay, so the sound O will be covered at least in 3 or 4 frames. That is, it will be repeated in 3 or 4 frames. Okay, so what happens here is, if you see the example here, the second one, cat, what I expect out of that sequence is just a word cat with 3 letters. Okay, but what will be probably recognized initially is the first frame will give me C. It is not single C, double C. Then there is that within the embeddings we have B. Either we have this representation, or we will have hyphen to represent the interval between the successive frames. Okay, so within the brackets, what we have, this B is actually the interval between the frames. Then I have A. It is not just one A, double A. Then I have T. This is one possible outcome of the model. The second possible outcome is the C, 2 successive intervals, A, another interval, B, another interval. So these, if you see, these are all the possible outcomes of the acoustic model. Now I have to find a proper word for this. So there are 2 things followed here. One is, if you take the first example, CC, first example, first part, double C. What happens is, within a frame, if something is repeating, I'm going to keep only one. So here I'm going to keep only C. The second C I'm going to neglect. Okay. So I'm going to, here if you take C will be retained, there is a pause. Second A will be retained, there is a pause. Second T will be retained, there is a pause. This is one step. Second step, I'm going to remove all the intervals and concatenate whatever text I got. Okay. So the intervals between C, A and T will be removed. Finally, I'll get the word cat. So if you take all the other possibilities, this is repeated. Okay. So the advantage is, if I'm going to, what is the advantage here could be, here cat, we have 3 unique letters. Okay. In case of good, G, double O, O, D, O is repeating twice. Okay. So in that case, I might have say multiple, like 5 or 6 frames, I'll have O repeating. Okay. I should get the proper word. What will happen? Both O's will be recognized because there is an interval between the frames. Okay. So all the values apart from the intervals will be written as such. Within a single frame, I'm going to remove the repetitions. So this model really improved the recognition system. This model was used as part of the recognition system, probably at the end, to improve the recognition performance. Okay, so these are my references. So what I was planning was, I wanted to give you an insight of the basic or the state of the art benchmark methods. We have a lot of benchmark methods as of now, but all of this is one way or other related to the methods I've spoken right now. So I want to give an insight. So with that, I came to the end of my presentation. So I'll be happy to answer any queries. Thank you, sir.
Speech technology, and she has touched upon some examples also, giving the cat as an example, how it is mapped in computer language. Various methods he has presented. The participants can participate by raising questions if you want to have any clarification over the issues she has narrated. She has touched upon various aspects of the present day situation. What are the things followed in speech recognitions, and the challenges he has also said that. Better, you can raise some questions. Friends, any question? Professor Umaraj? Professor Agilan, Professor Agilan, Professor Panis Narayanapillai is there, and even Professor Rajendran can also question.
Sir, let me speak 2-3 points. Sir is a good presentation about good hidden Markov model and the probability things and the N-gram model and how to make the language model, everything. It's a good presentation. But have you done anything related with the Tamil or Malayalam or any other language? Because you are all the examples are in the English way.
Yes, sir. Actually, I am currently working for Tamil. So basically, I worked in the toolkits Kaldi I mentioned. No, I worked for English mainly. So currently, I am working for Tamil in these toolkits. So I didn't include any research because I want to give an insight of what is available. So that is why I didn't include any research related to that. Tamil, I am working on it now, sir.
Okay, good. So simply saying, what is the role of phonetician or phonetician in your things? Phonetician means?
Yes. Main role could be in the language model, sir. Because, for example, if you take Tamil, it's morphologically rich and the dialect is too much, there is too much variations in the dialect. Okay. So that is a very big challenge in the Tamil recognition system, speech recognition system. So the performance depends upon the, I've mentioned, if you remember, the lexicons and the N-gram model. So this is actually a black box to a speech, the person who is developing a speech recognition system. This is actually coming from a linguist. The lexicon basically, it gives the phonetic sequence of a particular word. N-gram is going to, if it is going to be bigram model, it is 2. Okay, so the bigram model, if I'm taking, it will give me from the data, it will give me the sequence of 2 words. What are the possible sequence of 2 words? For example, if the first word is today, the next possibility is I cannot have Monday. Today, Monday, I cannot have. Today and is, there is a. So this sequence today is good morning, good afternoon. All these sequence will be part of the N-gram model. So this is very important. What happens in the initial phase is I identify the set of words corresponding to a noun. But the grammatical context only comes from the linguistic information. That is going to be the lexicon and N-gram model. So that is where the CNC came into picture. Connection is temporal classification. The last thing I told you, that is one of the advanced deep neural network method where the from the available sequence, I'll be able to correctly identify the required word or sentence.
Okay, but good things. Unigram, bigram, and trigram model. N-gram model is good. And suppose English is good. I am going to the market. If the sentence is I am will get. I am going to market. You will get. So that is bigram. I am. If I take to consider as a bigram, I am maybe ing form will come. But in Tamil, if I say that நான் தமிழ் படிக்கிறேன். So it is better to use the trigram model. The trigram model நான் தமிழ் படிக்கிறேன். Because நான் தமிழ் knowledge won't get that one. படிக்கிறேன், how to get that one. So the Phoenix model and the Stokes model, usually they use the trigram model. A unigram, bigram also good. But the trigram model is the better option.
Okay, sir. So in bigram, this is also available, sir. Nan படிக்கிறேன், நான் படிக்க போகிறேன். So நான் படிக்கிறேன், நான் படிக்க போகிறேன். So நான் படிக்க போகிறேன். 3 words are there. இல்லைங்களா சார்? So in that case, நான் படிக்க will be one sequence. படிக்க போகிறேன் will be second sequence. Yes, obviously as sir told, trigram model will have better results. But in bigram we have both the sequences also available.
Okay, நான் படிக்க போகிறேன். நான் படிக்க போகிறேன். I'm not that much expert on Tamil, but so படிக்கிறேன் is this unigram, bigram, trigram.
Yeah, the morphological structure.
Better option that is implemented with Spinix and the Spinix model for the automatic speech recognition, the Carnegie University. That's the things. Okay.
That's fine.
Yes, sir.
Okay. Any other question? Yeah. Of course, it's quite natural that we cannot apply all the methods applied for English language globally. Region-specific features have to be accommodated when we want to, go for the spoken language analysis. Of course, according to the need, we could modify the methods. Even the Python model can be modified according to the need of our language. Based on the linguistic corpus we developed, we could modify it. Okay, so instead of going for indigenous methodology, rather we could borrow a method from other language and we could adapt according to our need. Okay, so such a way you could compromise. Okay, anyhow, since there is no question at all, I sincerely thank for your nice presentation, and of course on time you have completed our lecture. Somehow it is very illuminating and it gives a lot of new ideas and the present day situation of the speech recognition being followed in the technical aspect. Thank you very much.
Thank you, sir. Thank you for this opportunity.
Thank you.
Thank you all.
Thank you.